Hello students and welcome to lecture 5 of unit 1, that is photochemistry. Here we will discuss the very important topics of fluorescence and phosphorescence. Have you ever looked into the plastic lights that are glow in the dark? Well, those substances undergo the process of fluorescence. There are also availability of phosphorescent lamp and other glow-in-the-dark materials, be it fluorescent dyes, etc. But have you ever wondered how or why the materials are glowing? Well, to understand the phenomena, we have to look much closer, even at a level which is smaller than the molecular level. Electronically excited state. What are electronically excited states? Well, electrons are a type of elementary particles, and for luminescence or for glow, luminescence, which is a photophysical process, the electronic transitions are responsible. When any system absorbs energy, the electrons are excited and they go into a higher energy state. Before excitation, in the ground state, they are in the HOMO, or the highest occupied molecular orbital. When they are excited, they reach the LUMO, or the lowest unoccupied molecular orbital. This will be clear from the energy level diagram shown in this figure. Now, these levels of molecules, these energetic states, they are called as energy levels, with energy delta E equal to E2 minus E1, where E2 is the final state and E1 is the initial state. Also, the energy of a photon can be given by E equals to h nu. Now, since we assume that the photon is responsible for the electronic transition, so E2 minus E1 will be equal to h nu. Then we can determine the frequency or the wavelength responsible for such electronic transitions. What is fluorescence? It is a molecular luminescence method, and the electronic transition that does not change electron spin, having a short-lived electron in excited state, causes fluorescence. Now, when we say no change in electron spin, or we talk about the singlet state or the triplet state, what do we understand? Let us try to understand what the singlet state is. As you can see in this figure, when the spin of the electrons are paired, this is one in one particular direction and the other electron in the opposite direction, since no two electrons can have all four quantum numbers same. This is known as singlet ground state. When this singlet ground state is excited due to the presence of a photon and the electron goes from lower energy level to higher energy level and the spin does not change, then it forms a singlet excited state. However, if such an excitation leads to not only change in energy level for one electron but also results in change in the spin, and the spin orientation becomes parallel to the unpaired electron, then this forms the triplet excited state. Okay. Now, what are the factors that affect fluorescence efficiency? These will be more clear if you go through the notes that I have linked with this video. So the structural rigidity, that is molecules possessing rigid structures, are better at fluorescence. So fluorine, which is structurally more rigid than biphenyl, is an excellent fluorescer. Fluorescer is the material that undergoes fluorescence or shows fluorescence. Then biphenyl, which is a weak fluorescer. Temperature is another such factors, because with increase in temperature, the degree of freedom, that is translational, rotational and vibrational motion of molecules, increase manifolds. Due to this increased motion of the molecules, there is possibility of collision of one molecule with the other, and that can lead to collisional deactivation and quenching of fluorescence. pH also contribute a lot in fluorescence. This will be clear if you read through the notes. What are the applications of fluorescence? Fluorescence finds its utility in mineralogy, gemology, chemical sensor or fluorescent spectroscopy, fluorescent labeling, dyes, biological detectors, as well as the very common fluorescent lamps. Now let us try to look into phosphorescence. What is phosphorescence? It is a specific type of photoluminescence. Phosphorescent material, as you will observe, does not immediately re-emit the radiation that it absorbs. This is because the excitation time scales or the release time scales are associated with forbidden energy state transitions, because you know that phosphorescence occurs from a triplet excited state to a singlet ground state. So that triplet to singlet transition is actually forbidden. It's not allowed, and hence the time scale for such emissions are very slow. The absorbed radiation is emitted at a lower intensity, and that emission will take up to several hours after the original excitation. Phosphorescence is a process in which energy absorbed by a substance is released relatively slowly. So, phosphorescent materials are also used to absorb energy and store it for a longer process, for a longer time, as the process required to re-emit light occurs less often. Now, what are the main difference between fluorescence and phosphorescence? As you can see, the figure explains a lot of the process, but you have to give every difference point-wise. So first you have to mention the definition, what is fluorescence and what is phosphorescence. So fluorescence is the emission of light by a substance that has absorbed light or electromagnetic radiation. Phosphorescence is the light emitted by a substance without combustion or perceptible heat. What is the time taken? So the fluorescence stops as soon as the light is taken away. That is, the source of the light is taken away. But phosphorescence tends to stay a little longer even after removal of the light source. What is the mechanism? So fluorescence takes place when excited energy is released from the singlet excited state to the singlet ground state. And phosphorescence takes place when the molecule is coming back to the ground state from the triplet excited state. What is the energy released? For fluorescence, the energy released is much higher than phosphorescence, and for phosphorescence it is much less. And what is the relationship between the absorbed and released energy? So in fluorescence, the absorbed amount of energy is released back, and in phosphorescence, the released energy is lower than what was absorbed. So with this, we come to an end of today's class. Please go through the notes once again, and if you have any doubts regarding phosphorescence or fluorescence or whatever we have discussed till now, do not forget to email me or WhatsApp me. I shall be available there. With this, I conclude today's lecture. Thank you.